Okay, we're continuing with our work on quadratic word problems. All of you have a copy of this. I handed it out yesterday. Get it out. Bailey, get it out, Bailey. Listen up. Dan, sit down, Dan. Asham. Kelsey, are you listening? Okay. We're all ready to go now? Let's think back to what we did last day. We had a set of steps in order to follow, and these steps will prove us well in this question on area. So have that handy as well. So step one, read the question, underline important parts. So important parts. A man has 1,500 meters of wire. He's going to construct a rectangular pen. He only needs to fence 3 sides because it's being built up against a barn. Find the dimensions of the plot that will yield a maximum area. Okay, so let's draw a diagram after underlining important parts. So we have a pen that's going to be built up against a barn. So there's the barn. Barn. Here comes the pen. Rectangular in shape. Okay, let's label. Since we're trying to maximize the area, area with a rectangle obviously involves length and width. So let's label this side as a length and this side as a width. Okay. Might as well label this side as well. Look back at our steps. We have read the question. We've underlined important parts. Check. We've sketched a diagram. Check. Let's now identify a quantity that's to be maximized or minimized. Well, we already said that's going to be area. Check. Assign letters to quantities. Let's go do that. Well, let's let W equal the width. Let's let L equal the length. And let's let A, since we're trying to maximize area, be the area. Okay. Now, next, we've assigned letters to quantities. Check. Create equations containing these quantities. All right. We could make a chart just like we did with that profit question the other day. One column would be width, one column would be length, and one column would be area. Okay, but we should be getting a little bit better at this. So I'm going to go right to the equation after I identify the parts. So we're trying to maximize area, and we're talking about a rectangle. What is the formula for area of a rectangle? Well, area of a rectangle is length times width. We can generate another equation from the numbers that have been suggested to us. The question says 1,500 meters of wire. So where does the 1,500 meters go? Well, it goes around the width, the length, and the other width. So we could say perimeter equals 2 widths plus 1 length, because we only have to fence one of the lengths because it's being built up against a barn. So, can we go a step further too and actually state what the perimeter is? Do we know how much fencing we have? Well, we do. We have 1,500 meters of fencing. So let's go a step further and say that the perimeter is 1,500. So that must equal 2 widths plus 1 length. All right. So we have 2 equations that we're going to concentrate on. We have the area equation, length times width for a rectangle, and we have a perimeter equation, which is 1,500 equals 2 widths plus 1 length. Okay. We've identified 2 equations. Let's now go back to our steps to see what's next. Step 5, create equations for quantities. Check. Step 6, combine equations by writing one equation in terms of the other. How can I combine these equations? And keep in mind, we're trying to maximize area. So that should be the main equation. So there must be some way to substitute in the perimeter equation into the main equation, area. If you remember from last day, step 7 says isolate a variable. We can, for the second equation, take 1500, move 2w to the left-hand side, thus subtracting 2w, equaling length. Length can now be substituted in for that first equation. Therefore, the area equals length. What is the length? Take a look. This is the length. Oh, I'll block that off. Here's the length. This can now be substituted in for length in that first equation. 1500 minus 2w is the length substituted into the first equation. So that would give us length 1500 minus 2 widths. So that's length times width, and width is just width. So I hope you all see how I substituted that length in to get that new equation. Okay, let's refer back to our steps. We've combined the equations now. Step 6. Now write the equation in standard form. Well, we actually want to write it in general form. So I'll do that part with you. Area in terms of width, that's the input, equals, multiply this through, you get minus 2w squared plus 1500w. Okay, let's refer back to the steps one more time. Step 7, we've now written the equation in general form. Mr. Winfield, I'd like you to pause this video for a second and let's see if the class can now complete the square, find the vertex, and write therefore statements for each statement. Okay, let's give them about 5-7 minutes to do it. And then you can press play to see us finish this. Okay, welcome back. Welcome back. Let's see how you made out. In order to find the width that develops the maximum area, we'll need to come up with the graphable quadratic. So the area in terms of the width equals factor out a negative 2, w squared, minus negative 2 times what is 1500w minus 750w. No third needed to factor out, so I'll need to complete the square. To complete the square, you take half of 750, which is 375. 375 squared goes here. I'll need to use my calculator to get that. 375 squared is, in green, 140,625. Okay. I'll make sure that fits in there. Okay, I've created a number. The number that I've created is 140,625 times negative 2. That's how much I've changed the equation by. So I've changed this equation by 281,250. That's how much less it is now. So I must compensate for that and add that number back, plus 281,250. So let's now write this in standard form. Standard form, area in terms of width equals negative 2 square root of w squared, w minus half of 750, 375, squared plus 281,250. Okay. As we said last day, the vertex usually contains part of the solution. So the vertex in this question, V, would be this parabola has moved 375 units to the right. The parabola has moved up 281,250 units. And it opens down because the A value is negative 2. Okay. Now let's take a look at this full solution for a second. So now we have the vertex. Now let's make sure that we've actually answered the question with a therefore statement. Find the dimensions of the plot so that it will be a maximum area. So the vertex is saying if the width is 375, because that was W, I'll put a little W up above, the max area is that. Okay? Let's just double check and make sure that that is indeed the case. So therefore statement. Therefore, if the width is 375 meters, I'm assuming, then the length is, now you have to substitute back. Go back and pull out that length formula. Length equals 1,500 minus 2 widths. Length equals 1,500 subtract 2 widths, and the width was 375. Okay? So therefore the length, L, equals 1,500 subtract 2 times 375. That would mean the length is 750. So therefore, if I take the width, which is 375, multiply by the length, which is a 750. This is a rectangle, so length times width should equal the maximum area. Let's check to see if 375 times 750 equals 281,250. It indeed does. So, in conclusion, we can say that if the width is 375 and the length is 750, the maximum area that can be built for this what are we talking about, a dog or a cow, is 281,250 meters squared. That's the biggest pen you could build. Okay? So I want you guys to try this at home. Go and tell your parents that you can now maximize the space in your backyard. Okay? Thank you very much.